right, welcome back, everybody. What are we doing? Math 35. This is lecture day 12. We are doing 10.5, which is on graphing quadratic functions. We're going to do 10.7, which is polynomial and rational inequalities. And if time permits, we will look at a couple of word problems, including one where Professor Hefe is a human cannonball. That's always fun. How many seconds are going to pass until Hefe hits the ground? Right? That's fun. People are like, fuck yeah, let's kill the teacher. This is great. Like Megan's all for that shit. That worries me. All right, so quadratics are ax squared plus bx plus c. Not the easiest thing to graph. But there are a couple things ways to make this graphing easier. Having an axis of symmetry is helpful. These make parabolas, I should say. Parabolas. If a is greater than 0, they open upward like that. And if a is less than 0, they go downward. Ones that open upward have a very smallest y value. We will have a minimum for y. And the ones that open downward have a peak. We will have a maximum value of y. And this min and this max, min or max, occurs at what is called the vertex. So that point at the peak or the bottom of the valley is called the vertex. So that becomes something that's really helpful to graph too. We're going to add that. Vertex is helpful. The axis of symmetry goes right down the middle of this bad boy. So the axis of symmetry is a line down the middle. Then things that are always helpful when graphing are x-intercepts and y-intercepts. We've done intercepts before, so we're going to talk about the intercepts first. Let's get that out of the way. X-intercepts are when what is true? What's the criteria for an x-intercept?
Y is equal to 0.
Thank you, Megan. Y equals 0. What about y-intercept? X equals 0. That's right. No fear. All right, so that's what we'll do. Those are pretty straightforward. For this x-intercept, y is the same thing as f of x. So we're going to solve ax squared plus bx plus c equals 0. We've done this in all of chapter 10. This is a chapter 10 problem. We can factor, we can complete the square. We can quadratic formula. Lots of things we can do. The y-intercept is fucking easy as pie. in this form. Y-intercept is when x equals 0. So f of 0 equals a times 0 squared plus b times 0 plus c. So it's c. And you get the point 0c. If you have it in this form, ax squared plus bx plus c. If not, and there's a good chance you won't, if it doesn't start there, you may not want to make it look like that. There's other ways to go. Vertex. Let me pause, make sure everyone soaks in that glorious wisdom. Vertex, we like to describe as H comma K. Because H and K don't get enough love in algebra. We don't use them a lot, so those are the letters that we're going to reserve for vertex. We actually use HK for a lot of things. We're going to have them in parabolas like today. We're going to have them in ellipses and hyperbolas later on. Circles. We're going to use it. It's roughly the center of the graph. And for something that goes on infinitely, that doesn't make sense. But when you look at it, you'll be like, yeah, I would call that the center. Even though it goes on forever, I would say it's the center. When we graph them, you'll see. How we get them is we want to write f of x in the form a times x minus h squared plus k. This is called standard form. K is just k. It's right there. Same sign as what you see in the equation. H is the opposite sign. So if it's positive, you're going to make it negative. If it's negative, you're going to make it positive. And if you have it written in this form, the axis of symmetry is x equals h. Here's ready for some examples. Now with this bullshit.
Yeah. Yes. The axis of symmetry that just goes straight through the vertex, right?
Yeah,
Yeah.
it's right through the vertex. And it splits the graph. All right. We'll start off with one in standard form. We want to find the vertex. We want to find the x-intercept, the y-intercepts. Generally, there's only one y-intercept. Sometimes there's more than one x-intercept. Sometimes there's no x-intercepts. I want this symmetry axis. And is it a max or min? What's the max min value? So remember, my vertex is in the form HK. And this looks like X minus H, and that's plus K. So what should I have for my vertex? -3, so it's the opposite sign of what's on the inside, and the same sign as the one at the end. -3, 1. So we'll put a point down for the vertex right there. -3, 1. I'm gonna call it B for vertex. This is my A. Recall, if A is greater than 0, they go up, and if A is less than 0, it goes down. So I'm expecting a graph that goes downward. And if we have any x-intercepts, it's kind of got to go downward. Right?
Yes.
So let's find that. X-intercept. X-intercept is when y equals 0. So this becomes 0 equals -2 x plus 3 squared plus 1. This is set up pretty well for extracting roots. I'll subtract 1 from both sides. This is stuff we did in chapter 10. Divide by -2. So I get 1/2 equals x plus 3 squared. And I'm gonna put the 1/2 over here because I like having the x's on the left. I hope you're all okay with that. What do we do from there?
So,
Take the square root of both sides. This is square root of 1 over square root of 2 is 1 over square root of 2. And remember, when we rationalize the denominator, we want to get rid of the square roots. On bottom, we get square root of 2 over 2. So x plus 3 equals square root of 2 over 2. And it's plus or minus because we took the square root. Finally, we subtract 3. We get -3 plus or minus square root of 2 over 2. We want to use that. That's our x value. So our points are that comma 0. That's not really graphable though, is it? So we're going to want to find a decimal at this point. Where is my calculator? That's not it. So -3 plus or minus 0.707. I'm going to have -2. We'll say -2.3. We'll go to 1 decimal place. And -3.7. Alright, so that puts a point. Closer to the -4 and the -2. Not a lot to go on yet. So there's our x-intercepts. Y-intercept is when x equals 0. So I've got -2 times x, which is 0, plus 3 squared, plus 1. Y equals -2 times 9, plus 1. And that adds up to -17. Holy shit, I didn't make my graph big enough. It's way the fuck down here. We'll say that's -17. Because I didn't make my graph big enough. That's the point 0, -17. All right, I'm going to use like a regular pin to do the axis of symmetry. The axis of symmetry goes through the vertex. Axis of symmetry. It's got the same h value as the vertex, so it's x equals -3. How do we use it? Well, we can make sure the x-intercepts are equally distant from that axis of symmetry. They're both 0.7 away from it, which is good. The other way we're going to use it is for the y-intercept. We are going to mirror the y-intercept over the axis of symmetry. So this is 1, 2, 3 steps. I'm going to go 3 steps the other direction and put a point there. So that's 0, -17. This will be -6, -17. Now I've got 5 points and I can connect them. The top is rounded. It's rounded. Don't do this shit. It doesn't have an edge. It's not a vampire tooth or fucking fang or anything.
And that's mostly because there are kind of decimals in there that kind of abide by that same curve.
Yeah. It's more because it's the square root of a decimal, which means the change starts happening really slowly
As it gets closer to the curve.
as it gets closer to the vertex. Any questions?
What's the maximum then?
So, oh, you're right, I didn't do that. So the max and min occurs at the vertex. Is this a max or a min? It's a max. All the y values are less than it everywhere else on the graph. It is definitely a max. The vertex was -3, 1. So we have a max value of 1 at x equals -3.
The maximum or minimum is just where the vertex is.
Well, yeah. Because every other value is less than it on this graph. And you can see that visually. And when it opens upwards, the vertex is at the very bottom of the graph. So all other values are higher up than it.
It's just the y then.
Yeah, it's the y value. So max or min is y value at vertex. Ready for more?
Yes.
Minus. Well, that should be a -9. Let's come back to that one. Let's complete the square on an easier one first. Let's start off with f of x equals x squared minus 8x plus 12. So this form is easiest for intercepts. So let's grab them real quick. X-intercept y equals 0. X squared minus 8x plus 12 equals 0. This factors into x minus 2 and x minus 6. And when we solve, we get x equals 2 or x equals 6. So our x-intercepts are 2, 0 and 6, 0. My y-intercept is even easier. Plug in x equals 0 and I get 12. So 0, 12. So before we even continue doing the rest of it, I'm going to sketch what we have. I can give myself a lot of room. Let me do little subtabs. Two, 4, 6, 8, 10. So that's our 12. That's 5 right there. 4, 8, 12. So I've got 0, 12 is way up here. 2, 0 is way down here. And 6, 0 is way down here. A, which is the number in front of the x squared, is positive or negative? It's greater than 0, it's positive, so does it open up or down?
No.
It opens up. So it's reasonable to think that this is gonna be like this, come down like this. Cross here. At some point in the middle, it's gonna change directions and start coming back up. Cross at 6 and keep going back up. And with our crossings at 2 and 6. Do you guys have an intuition of where that vertex might be at least in terms of x? 4. The vertex is generally like midway between them. The x value at least tends to be midway between x-intercept 1 and x-intercept 2. The reasons why I say tends to be is because we don't always have intercepts. Not every graph crosses the x-axis. Y equals x squared plus 1 does not cross the x-axis. Doesn't cross the x-axis, so there's no x-intercepts. So you can't always use that for information. So let's treat this now. Let's go on to do the complete square. And what I'm going to do is I'm going to leave a gap, but I'm not going to move the 12 to the other side. Oh, I didn't leave a gap.
It's 8x.
It's 8x, not negative 18. Thank you. That was really going to change the problem. So the important thing to know here, since we're going to do everything on the same side, all activity on the same side for this. So whatever we add, we have to subtract. For a net change of 0. We don't want to change the value of the equation. Like when we did complete the square before, we used to add the same thing to both sides. Now, instead of adding it to the other side, I'm just going to subtract it from the same side. If it makes you feel better, you can add it to both sides, but then you need to get f of x by itself. So you're going to subtract it over. Okay? But to complete the square process is the same. Bring that bad boy down, chop it in half, square it. -4 squared is 16.
Right, and then when you bring 16 over, it's negative, right? It's not positive. But it's
Here it's negative.
or color.
So I added 16 on the inside. I'm going to subtract 16 on the outside. So that rewrites this equation as, and completing the square, this is what falls into the parentheses. -4. X minus 4 squared and 12 minus 6 is -4. My vertex is where? 4, -4, right? So if our intuition of 4 earlier was correct. I'm going to pencil in a nice little axis real quick. just so I can reflect this on the other side. So this one we get by reflecting over axis. We're taking advantage of the symmetry. Finally, we'll sketch in the curve. Are we having fun yet?
Ooh, this is the fun zone class.
This is good shit.
So this is a min at a -4 and x equals 4.
Yes,
Exactly. This is a min of -4 at x equals 4.
is this not your favorite class?
This semester,
Yes.
I think it is.
Same, but it was like 10.
Well, that's part of what makes it my favorite. There's a lot less to grade in here.
That's true, actually.
And I consistently ask you all the time whether or not this is fun or not. And no matter what you answer, I fucking have fun with my response. And I do it all the time. And I don't really do that in the other classes. Now, I am teaching computer science a lot, and like they have an exam coming up, like computer science 2 has an exam tomorrow. And I'm making one of their problems Dungeons and Dragons related. So I'm having my own fun with them that way. But they don't participate as much in class. They're like, they want to be programmers. So picture the geeky nerdy bunch. That's them.
You don't want to be a programmer?
I'm not judging, I'm one. I teach the shit. I'm clearly not judging because I couldn't teach it if I didn't know what it was. I'm a guy on Big Bang Theory. All right, let's do a harder one. I'm not gonna do it all the way through because I think we've seen the graphing. The one that makes this difficult is the completing the square. So how we're gonna go about completing the square? I'm gonna show you what I'm gonna do. And I put a little space in there. Whatever this coefficient is in front, I'm gonna use it. I'm gonna multiply this by -2 over -2. And I'm gonna take this bottom part and move it inside as a denominator. So what will happen is I get the -2 on top, that stays outside the parentheses. And then I'm gonna divide -2 into each of these. The only reason I'm showing, the reason I'm showing it like this is because I've done -2 over -2, which is 1. I am not changing the value of this equation. I'm multiplying by 1. I'm doing it in a creative way such that this becomes x squared. And 8x divided by -2 is -4x. And still got my -9. Is everyone okay with that part? Is your hand up, Jackie, or are you just stretching?
No, we're good.
Okay, so. We're gonna complete the square. -4 divided by 2 squared is -2 squared, which is 4. What have I really added on this right side? It looks like we've added +4. That's not true. Because this is in parentheses. And that parentheses is getting hit by -2. What I've really added is -8. Now, if you want to see that real quick, let's distribute. If I distribute real quick, just to show where it's coming from, I get -2x squared plus 8x. -2 times 4 is -8 minus 9. Right? If I distribute this part, and this part are all the original equation. Which means this is what I added. We can see them up here, -2x squared, 8x, and -9. I've added -8, and I don't want to add -8. So I'm going to subtract -8. I'll do that up here. Which the effect is adding 8. But that way, when I finish doing the complete the square, I got the -2 out front. This is still the normal version of completing the square. But now I've got that -9 plus the 8 is -1. Are you guys okay with that? I don't know if there's a lot of problems like that on the test or not. There's a much easier way for all of this. But you had to feel the struggle, know the burn to accept what I'm about to give you. The gift that I'm about to give you. We are gonna go back like we did when we found the quadratic formula. I'm gonna complete the square with ax squared plus bx plus c. Let's do that same process here.
Yes.
So what effectively happens is I have x squared plus b over ax plus c. When I factor out the a. We multiply that by 1/2 and square it. I am adding plus b over 2a squared. And so I'm going to subtract b over 2a squared. So I get f of x equals a times, remember it's this thing, x plus b over 2a squared. And then I've got, if I get a common denominator here, this is b squared over 4a squared. Which looks a little weird. And so if I wanted a common denominator, I need a 4a squared up here with the c over 4a squared. And now it looks ugly as hell. But that's kind of like my plus k. So completing the square gives us that.
Can you use the quadratic formula for that?
This isn't quite the quadratic formula. It looks similar to it, right?
Right.
We got a b squared, there's a 4ac, but since we never took the square root here, we didn't get the quadratic formula. But you do not need to memorize that. That looks like a bitch to memorize, right? This is following x minus h squared plus k. What is H?
No, yes.
B over two.
It's B over two A, but it's the opposite sign. Rather than memorizing that for your K. What happens if I plug in negative B over two A? If I put in X as negative B over two A, what is this overall parentheses? 0, right? And so whatever's left here. Is the value at the vertex. So rather than memorizing that, we're just gonna say that's K. And that's easier to plug in. You'll get a value here and we'll just plug it in and it'll be good. So to wrap up the glory of that, you don't need to memorize that entire process. Another way of doing the vertex is negative B over two A. F of negative B over two A. And let's go back and look at that negative two X squared, the one we just did. The one that you didn't like. So what is H here? B is the one in front of the X, so I've got negative 8 over 2 times A is negative 2. This is negative 8 over negative 4, which is positive 2. And to find my K, I'm just going to stick in 2. And calculate. This is 2 squared is 4 times negative 2 is negative 8. Plus 16 minus 9. 16 minus 8 is 8. 8 minus 9 is negative 1. So my K is negative 1. My A is still what's out front. That's still A. So if I want to do A times X minus H squared plus K, I got my H and K right there, and I got my A up above. Negative 2 times X minus 2 squared minus 1.
It's just another way to do it by like without completing the square.
Well, the process used completing the square. This is like doing the quadratic formula version.
Yeah.
We did all the hard work. We're memorizing formula. But it's an easy formula, right? You take the middle number, you divide it by twice the first number, and you make it negative. And I'll bring that other equation back down. That's what we got doing the complete the square version. And the complete square version had all this clusterfuckery. So. That's the takeaway. The vertex is at negative B over 2A, F of negative B over 2A. And everything else, your x-intercept, your y-intercept, you do the same way. Let me give you guys 2 equations to find vertex for.
negative and put something else.
No. I mean, I could let you, but I'd be fucking you for the next class. And I'm not supposed to fuck students, that's against the rules.
What if? So will it still then pass with the notebook? With the,
Honestly, you'd be surprised how many don't still pass. Cause they haven't been taking notes, so the notebook doesn't do any fucking good if you haven't taken notes or done any homework, it doesn't help you. But I wouldn't be doing you favors. You may think it is, but in the long run, most of you are pursuing a degree where you need to know this stuff. I say most of you because Jackie's like, I don't want this shit. I want to stab people repeatedly with fucking small needles. And not draw blood. That's just fucking twisted,
yikes.
right? Alright. So I'm gonna do negative B, which is -2 over 2A, A is 1. I get 2 over 2 is 1. And if I find my K, 1 squared minus 2 times 1 minus 3. 1 minus 2 minus 3 is -4. You got 1 -4, you've done good. Is that a max or a min?
Yeah.
Why?
It's-
A is greater than 0, so it opens up, which means, yeah, it's a min. It doesn't hurt to like do the little picture and if it helps you. All right, we'll come along and do this one, and then we'll take a break. So -12 over -6 is 2. G of 2 is is 24 minus 12 is 12 minus 2 is 10. Max or min?
Max.
It's a max. A is -3, which is less than 0. So it opens down and we've got a high point, a max. How would I write this in HK form?
Wouldn't be, X minus 2.
We will have H was 2, so we'll have X minus 2. What else?
Plus 10. Oh, you need the -3 in front of that.
And I need the -3 in front of that. Yep, and that would be it. All right, let's take a 6 or 7 minute break. Stop this video.